Welcome back, everyone. I'm Jordan Giesige, and this is The Limiting Factor. Today I'm going to do a walkthrough of everything that happened with Tesla that's battery related from the month of October. Tesla held a series of events in October, from the annual meeting to the opening of Giga Berlin to the quarterly report and earnings call. Those things don't warrant a deep dive, but people have asked me a number of questions on them, so like last quarter, I think it's worth walking through those so I can share my thoughts and views on what we saw. Now, before we get into it, I'd like to make two notes. First, a special thanks to my Patreon supporters and YouTube members. Those are the contributions that make the channel possible. Second, I expect in the next 3 to 6 months that vehicles containing 4680 battery cells will start hitting the market. Unfortunately, some of those vehicles will get into accidents, but it does present us with an opportunity. I'd like to get my hands on one of those 4680 battery cells and send it into a lab for comprehensive testing. The reason why I'm sharing that with you is that I'm hoping that you out there can be my eyes and ears, and as soon as one of those becomes available, I can ship it off to a lab for testing. And I have a list of, I think it's at least 10 tests that I'd like done on the cells, but we won't get into that now. As soon as I get the battery cell, or if I get my hands on one, then I'll share more. With that in mind, let's get started with the annual meeting. As always, the highlight of the annual meeting was a keynote talk by Elon. Towards the end of the keynote, he said that Tesla would shift headquarters to Texas, but he added this about the Fremont factory. Our intention is to actually increase output from Fremont by 50%. It's spam in a can here. This doesn't seem battery related, but in a way it is. There's 3 ways that I see Tesla could increase the output from Fremont. The first is to increase the throughput. The second is to make better use of the floor space through things like the Gigacasting machines. And the third, which is where this ties into batteries, is they could use modular Z construction and build up. The reason why it's battery related is because we've already seen this in the Cathode Road facility. Now, I see modular Z construction as less likely, but I thought I would bring it up because it might be of interest to people. If you'd like to know more about that and Agile at Tesla, there's a great video on this by a guy named Joe Justice, so look that up if you get some time. Let's move on to Q&A. The first question that's battery related is, when will Cybertruck production begin and at what rate will the ramp happen? And the response was, well, so this year has been a constant struggle with parts supply. If we had 5 extra products, we would not change our vehicle output at all because we're just basically limited by multiple supply chain shortages, not just chips. It really wouldn't matter if we had like the Semi or Cybertruck or anything. We wouldn't be able to make it, and the Semi in particular needs a lot of cells. So it needs a lot of cells, a lot of chips. This year I've received a lot of questions and concerns from people that the 4680 ramp was causing delays in vehicle ramps and the launches of new products. Now, I've consistently said that I don't think that's the case, that the 4680 in some instances might have something to do with it, but it's probably due to other factors and the situation is more complex. And that's basically what Elon is saying here. In fact, in the Q2 earnings call, which we covered 3 months ago, he said this, which is even more specific. I mean, it's worth noting that if we had everything else, if we had the best numbers of vehicles themselves, we would not be able to make them. Everything except the chips, we won't be able to make them. The chip supply is fundamentally the governing factor on our output. Now, you can't get any clearer than that. However, he did add some detail at the annual meeting, which was helpful. So I think most likely what we'll see is Cybertruck production in the next year, and then volume production in 2023, and hopefully we can also be producing the Semi and new Roadster in 23 as well. I think the chip shortage, the back of it will be broken by next year, but we'll see. So I think any delays that we're seeing into mid next year or towards the end of next year are due to the 4680 ramp. Now with the Model Y, I didn't see it was likely that the 4680 was causing delays in the production ramp because the Model Y can fall back on the 2170 cell. The Cybertruck is a different beast. I think it pretty much has to use the 4680 cell unless we're talking about the short range version. And I'm assuming Tesla will start with the longer range versions of Cybertruck that have a higher margin. However, that still doesn't necessarily mean that the delays in Cybertruck are due to the 4680. I think Tesla's plan was to ramp the Model Y from July to December of this year and then taper the resources over to the Cybertruck as that ramped. But because they don't have enough chips for the Model Y, they've had to delay that. So it makes sense now that the Model Y would ramp from January to June of 2022, and after that they start ramping the Cybertruck and they hit volume production in 2023. The way things are looking, mid-2022, there should be plenty of chips for all those vehicles. And the 4680 should be ramping in Austin and Berlin in the first half of 2022, on into the second half. With regards to the Roadster and the Semi, I think that's much higher likelihood that that's due to delays with the 4680 ramp, because the Semi is so cell hungry, and the Roadster, it's cell hungry as well, and it doesn't require many chips. So to me, it seems like the reason why those are delayed are due to the 4680 ramp issues. Now, Elon had one more response to the question about when the Cybertruck would begin production, and that was, so we should be through our severe supply chain shortages in 2023. I'm optimistic that'll be the case. We will see. I think it's worth emphasizing what's happening here and what Elon's saying. First, even though a moment ago I just said that the 4680 would most likely cause the delays with Roadster and the Semi, it's not necessarily the case. They still could be having supply chain shortages in other areas. Second, Elon's generally an optimistic person, and he usually gives timelines that are aggressive. So if he's saying they could still be having supply chain shortages in 2023, it tells you just how much pain they're experiencing right now and how dire things are. And with that, let's move on to the next question. Will we see 4680 battery cell production in Texas? Elon's response was, I don't think we will see 4680 production in Texas this year, but we are making 4680s in California at our pilot plant. I think we already assumed this based on the information from the Q2 earnings call. Elon goes on to say that factory will be able to make more than enough cells for Giga Texas to scale production of the Model Y. A lot of people have interpreted this to mean that Tesla will use 4680 cells to ramp the Model Y from Giga Austin from the very beginning, and that's not necessarily the case. I think it's likely the case, but Elon's words weren't specific enough here, because scaling is kind of a generic word. You can mean that to be at scale, you can mean it to get to scale, and getting to scale, there's several different stages to get to scale. So it's not definitive enough for me yet. And we'll talk a little bit more about that when we move on to the Q3 earnings call. He also said, I also expect we will reach high-level production of the 4680 cell here in Giga Texas next year as well. Again, this is pretty much what was said in the Q2 earnings call. So there wasn't a lot of new information in the annual meeting. The next question was, when will we not need to do any more mining for batteries? Elon's response was, basically, it will be a while because we have got to extend the fleet. I'll expand on this a little bit. Vehicles last 10 to 20 years, let's say 15 years on average. Meanwhile, EV manufacturing is growing on an exponential curve. So if we look back 10 to 15 years, if we're recycling the batteries from 10 years ago, from the production from 10 to 15 years ago, then we're only meeting about 10% of our needs for raw materials. I do totally agree with J.B. Straubel that we can mine drawers around the country where people have leftover electronics, and we can use that lithium for vehicles. But it's only going to satisfy about, at most, 10% of the demand. So it's going to be probably 2030, 2035 before recycling starts making a significant dent in the raw material needs and drives down prices. Elon goes on to say, lithium is extremely plentiful. It's one of the most plentiful things on Earth. It's not rare at all. It's hard to avoid lithium. I totally agree with this. And people often bring this up to me that, hey, we're going to run out of lithium. And the answer to that specific question is no, of course we're not going to run out of lithium. But where I think Elon missed an opportunity here is to clarify what the bottleneck for lithium production is. The bottleneck for lithium production is permitting mines and building all the manufacturing infrastructure around taking that abundant lithium material and turning it into a finished product for vehicles. And I think he missed an opportunity here to provide a bit of comfort for people like me that are concerned that, around 2024, 2025, lithium might start becoming a bottleneck for the production of lithium-ion batteries, because we're just not seeing the upstream material production that's going to be needed to produce all these batteries. I'm not saying that it's impossible that we'll solve that problem. I'm saying it's not looking promising at the moment, given that the lead times for mining and production is 5 to 8 years, and that's going quickly. Elon goes on to say lithium is only maybe like 1 to 2% of the battery cell. Again, I agree. It is a minimal component of the battery cell, and the key concern that they would have right now is the cathode, which we'll come to in a second. But if you're missing lithium out of your lithium-ion battery, you can't produce lithium-ion batteries. It's like Elon has said in the past, you have a vehicle with thousands of parts. If you're missing one part, you can't produce that vehicle. And lithium is more critical to lithium-ion batteries than most components are to a vehicle, because you just can't make the batteries without it. There are no alternatives currently. Sodium-ion might become an alternative, but it's going to be a while before we see that. I don't see that we're going to see high-volume production of sodium-ion batteries this side of 2025. The next thing Elon says is, and so the actual thing that matters is the cathode, moving to an iron-based chemistry. I think that the vast majority of batteries in the future will be iron-based. And I totally agree here. The first thing they need to focus on is getting that nickel out of the battery because it's not as abundant as iron. However, soon after that, they may hit bottlenecks with lithium. And I can see, it kind of feels like Elon is dodging the question here a bit. And I fully understand that because there's no sense spooking the horses about something that won't be occurring for another 4 years. And I'm assuming Tesla is in a better position than most companies in the industry. And they may never run into a bottleneck, especially if they start cannibalizing the lithium production of other people. But that comes with a lot of caveats. So I couldn't say with confidence that Tesla is going to have enough lithium. So once again, I would have liked to have heard a bit more here. And then he says, so I do not see any shortages. It's just a question of making all the equipment to kind of process that into a cell and then into a pack. And that's what I was saying earlier about the upstream supply chain. Maybe he knows something, well, I'm sure he knows something that I don't. I'm curious about how far along they are with their lithium production in Nevada. I haven't seen any permitting or any information yet that indicates to me that they have everything lined up for lithium production in Nevada with their clay. But they could be partnering with somebody. I haven't heard anything. So again, my curiosity is piqued here. He seems confident, and I want to know why he's confident. The next question is, what about electric planes? This is one of my points of passion, something I want to do a video on in the future. But continuing on, his answer was, an important metric is to get the cell energy density around 450 to 500 watt-hours per kilogram and have a pack efficiency of around 400 watt-hours per kilogram. That's when electric planes start to get interesting. In the past, Elon has said that about 400 watt-hours per kilogram is required, but I don't know if he specified whether that was 400 watt-hours per kilogram at the cell level or at the pack level. I was always suspicious of the 400 watt-hours per kilogram because at the cell level, that's not enough. You need about 500 watt-hours per kilogram to make a decent regional jet, even with Tesla's technology. And if you want to make a medium-range jet or a long-range jet, you need more like 700 watt-hours per kilogram or 1,000 watt-hours per kilogram. This does give us sort of a time frame for when we should expect an eSuperVTOL from Tesla. I don't expect us to have long cycle life, high energy density batteries with high power output and high charging speeds until the late 2020s, if not the early 2030s. I've said in the past that I think Tesla should probably start designing an eSuperVTOL around 2025, and then by the time they get through all the regulatory hurdles, it'd maybe be 2032 to 2035 before they could launch an eSuperVTOL. So I would say start keeping your ears perked from 2025 onwards for an eSuperVTOL. I'd love to be wrong. I'd love them to start it now, but I just don't see that the energy density is there yet. The last question that was asked at the annual meeting was, what's the target capacity for the Megapack factory? And Elon's response was 40 gigawatt hours. Now, that's a lot more than I was expecting, so much so that I'm going to have to change my forecast. I had predicted that most of Tesla's battery supply would be going into vehicles until the mid-2020s, and then after that, energy storage would take off. But I'm wondering if that's been accelerated now because of the chip shortage. Vehicles tend to take a lot more chips. So if Tesla doesn't have enough chips to go into vehicles, maybe they can use those chips instead if they have a fewer number to produce energy storage products instead. Now, I don't know if this is the case. This could have always been the plan, but it seems interesting to me, or coincidental, that the time when they're running short on chips and they have a whole lot of battery cell supply coming online, that they might have to divert those battery cells to energy storage products instead. Now, a number of people have asked me what type of battery cells I expect them to be using for those 40 gigawatt hours. My first guess would be CATL LFP batteries. Tesla's also shifting their line of standard range vehicles over to LFP, which that will free up a lot of nickel, but I would think it would make a lot more sense for those 2170 battery cells to be used in vehicles and power walls, and to use LFP batteries for the Megapacks. But again, this is all speculation on my part. That wraps up all the comments Elon made at the annual meeting that were battery related. And with that, let's move on to Giga Berlin. There was one comment that was made in his speech that we need to cover, and then there's a whole lot that we have to cover in the walkthrough. After Elon's speech at Giga Berlin, somebody asked the question, where will battery cells come from until the Berlin cell factory is complete? Elon responded, for initial production, they'll be coming from outside of Europe, most likely China, until we have the cell factory reach volume production by the end of the year. First, the volume production part isn't new. Elon said as much in the Q2 earnings call. However, the part about cells from China is new. Cells from China could either mean 2170 battery cells from LG Chem, or it could mean CATL LFP battery cells. My bet is on the 2170 cells from LG, because my guess is that Tesla will start with the higher trim models of the Model Y and Berlin first, and then work down from there. With that out of the way, let's get into the walkthrough. I want to start by thanking the Tesla Check YouTube channel for providing these crisp 6K images that we can zoom in on. Thanks, Andrew. Much appreciated. Another note before we get into this is a lot of people assume that what we see here is what Giga Berlin will actually be producing or using in their vehicle lines. That's not necessarily the case. These are displays. Starting with the 2170 battery pack, Monroe & Associates confirmed the vehicle structure we see here is an early version of the Model Y, and it's likely not representative of what will be coming out of Giga Berlin. This means it would have come from Fremont. As for the 4680 battery pack, it's clearly incomplete. When we zoom into the front, we can clearly see that the battery cells are using some type of facade. Battery cells are wound, which creates a layered effect when you slice through them, and I've seen this done many times before. I wouldn't recommend doing this at home. You could have the battery explode in your face. From there, it looks like the battery cells are floating in space. No wires, no connections, no supports. As we can see in the image from Battery Day, there appears to be what looks like cooling channels below the battery cells. Whether that's actually what they are remains to be seen, but I don't think we can reliably tell from this image. Then, if we look along the side, there's no circuitry or wiring. We do see what appears to be cooling ribbons like those that are used in Tesla's other vehicles. However, this doesn't yet confirm whether Tesla is using plate or ribbon cooling for the pack. With all that said, these images do tell us something important. It's something that I've been saying and Monroe & Associates has also been saying. The 2170 battery pack has unnecessary redundancy. You have the steel case of the battery pack, which is rigid and can serve as structure to keep the battery from twisting, and also a structural floor pan that does exactly the same thing. In the 4680 battery pack, the pack itself serves as the structural floor pan, and it's only one layer of metal. For me, there doesn't appear to be a reason why this can't be done with the 2170 battery pack as well. The 4680 uses cells for rigidity, and the 2170 battery pack uses steel beams. For me, what this all means is that the door may still be open for Tesla to use the 2170 battery pack as a structural component. It would just be heavier than the 4680 battery pack because it would still be using steel beams. If that's the case, the 2170 and 4680 battery packs could be made interchangeable at the Berlin factory. My gut feel is that they're not going to do this because it would require redesign and would be temporary until Berlin starts using the 4680. But I think it's important to cover it because it provides a better understanding of how the structural battery pack works. That is, it not only removes duplication in the underbody of the vehicle with the structural floor pan, it replaces the steel beams with batteries, which makes the pack lighter weight, more rigid, and increases capacity. Next, let's cover off the 12-kilometer roll of anode material they had on display. A lot of people ask me if this came from Panasonic at Giga Nevada or Tesla at Cato Road. My view is it most likely came from Cato Road because in the Q2 earnings call, Tesla advised that they were having issues with the cathode side, but not the anode side of the production process. So you may as well grab the material from the side that can actually produce that anode roll. There's also another thing to take into account, which is that Panasonic at Giga Nevada and Tesla, even though they're in the same building, there's a strong partition between them. A lot of people think it's this open organic relationship. There is a lot of communication between the two parties, but everything that Panasonic does is behind closed doors because it's trade secret information as to how they run their lines. Beyond that, there's one more thing we can stack on the Cato side of the equation, and that is this tweet by Alex Torville. Alex Torville, it sounds like he has some connections in the Cato facility, and they confirmed that this is called a mother roll, and that Tesla can actually produce 40,000 cells from that roll after it's been divided into 16 individual electrode belts. So thanks to Alex for that nugget of information. It's a nice bit of trivia. If you want to know more about how the 4680 cell comes together at Cato Road, he's done an excellent video on that. I highly recommend it, and I will link it in the description. Let's move on to this image, which shows cell wiring. Again, this is another great image from the Tesla Check YouTube channel. All the other images I saw online were kind of blurry, and this gives us a really high definition look at what's going on here. There were three options I showed or mentioned in previous videos for the wiring at the top of the battery cells. The first was a gasket, the second was a printed circuit board, and the third was plain metal connectors. It looks like Tesla has chosen the plain metal connectors. Along the side, you can see the circuit board, but this isn't new. It's similar to what's being used in other Tesla vehicles. That wraps up the Giga Berlin tour. Let's move on to the tabless cell leak. When I say the tabless cell leak, I'm referring to these hubcap looking devices that sit on the top and the bottom of the battery cell before it's inserted into the battery cell casing. In this video, I'm just going to focus on what the purpose of this hubcap looking device is. And once again, if you want to know more about how the battery cell comes together, you can refer to that video that I've linked in the description, which is also from the XPod, official XPod podcast. Now, I've thought quite a bit about what this could actually be for, and it's mostly left me stumped. There's a couple things that are obvious with it. First off, it's for electrical connectivity because it's copper and it's metal, and it attaches to the electrodes on the top and bottom of the battery cell. And it probably also serves a function for manufacturing. Again, that's in the video linked in the description. However, beyond that, they could have solved those problems in a number of ways. Why did they choose this design? To answer this question, the first thing I think to do is ask myself what's different about the 4680 battery cell. Why would it require this metal sheet at the top and bottom of the battery cell? The first two things that come to mind are the fact that the battery cell is larger, the 4680 cell design versus the 2170. And the second thing is the tabless electrode at the top and the bottom of the battery cell. Now, before we move on, it's worth pointing out by tabless electrode, they mean these thousands of tabs that you see at the top and bottom of the battery cell. We're going to refer to those as flags rather than tabs. So starting with the larger cell size, I don't think that's directly related here. I don't think that's the reason why you need these sheets of metal on the top and the bottom. The larger cell size only comes into play because as you increase the size of the battery cell, you need more heat dissipation. And that necessitates the use of the tabless electrode. And so for me, it's the tabless electrode is the main difference between this battery cell and other battery cells. Well, why would a tabless electrode, those thousands of flags at the top, why would that need a piece of metal at the top and the bottom? My view is that the tabless electrode, those flags are kind of like the hairs on your head. And if you have those pressed up against the top of the battery cell, it's going to disturb those as the battery is vibrated. Those foils are only about 10 microns thick, which is that's about the diameter of a red blood cell. So these are very sensitive to any sort of friction. I think what those metal sheets do at the top and the bottom is it's almost like a helmet. It compresses the hair down, and if you instead of trying to rub somebody's hair, you get the helmet instead. So put another way is if you have these metal sheets on the top and the bottom, it acts as a proxy or a barrier that protects the tabless foils or the flags at the top and the bottom. I hope that makes sense. But yeah, that's my view. I think that's the primary purpose. Tacking down the tabs at the top and the bottom with that metal sheet, it both holds those flags in place and it also protects them from friction at the top and the bottom of the battery cell, while also being a current collector and probably also serving as some sort of facilitator for manufacturing. Now, there's a lot of promising views out there as to what those are for. Some other people have said that it could be for expansion and contraction. That could be the case, but usually the expansion and contraction happens along the width of the battery cell rather than the height. So I don't know if that would play a part. However, there will be more silicon in the 4680 battery cell than other battery cells, so it might need something like that. Another theory is it has sort of like a spring effect on the top and bottom of the battery cell. To me, that seems less likely because the battery cell is packed in there so tightly that it can't move back and forth. So the spring effect, it wouldn't provide any benefit because there's nothing that's sprung under that weight. It's the battery cell is already locked in place and it can't move back and forth. And finally, it could just simply be providing a little bit of extra space at the top and the bottom of the battery cell for protection. But to me, I feel like I'm onto something with the hairs, but we'll see. That wraps things up with the tabless electrode leak. Let's move on to the Model S Plaid battery pack teardown. I wouldn't really call it a teardown because everything wasn't completely pulled apart. We didn't get a deep look inside of it, but it was enough so we got a good feel for what that battery pack is about. The YouTube channel that did that teardown was called Ingineerix, and it was from a salvaged Plaid Model S battery pack. Let's look at the highlights. First, he states that the battery pack was using 18650 battery cells. I made a video months ago about why Tesla would use 18650 battery cells in the Plaid Model S. And this serves as double confirmation because we also saw in a wreck earlier this year that there was some 18650 cells lying around. But if anybody had any lingering suspicions, this should put those to rest. The battery pack still uses modules, but it's also more advanced than the battery pack in the Model 3 and the Model Y. Again, I suggested this would probably be the case in the 18650 versus the 4680 battery video. I said what they could do is, rather than continue to use the old 18650 pack, they could take all the technology that they put into the Model 3 and the Model Y and incorporate it into that Plaid Model S battery pack and potentially make some further improvements. If you're familiar with what the old Model S pack looked like, The improvements are obvious just from a first glance. This pack uses 5 modules instead of 16. That'll make the pack lighter, easier to manufacture, and more energy dense. Now, I'm assuming that under each of the orange covers is a steel beam. The side shots appear to be showing those beams sticking out along the sides. And what this means is that the battery cell isn't being used as a structural member within the battery. However, the pack still has rigid structure that Tesla might be able to take advantage of. For instance, they might be able to remove the structural floor pan and just use the battery pack itself as the structural floor pan. As I pointed out, and Sandy Monroe has pointed out, it's just redundant having both the battery pack and the structural floor pan underneath the vehicle. Now again, I'm going to link that video in the description so you can take a look for yourself and see if anything jumps out at you. Next up, we're going to cover off the quarterly report, and then we're going to move on to the earnings call and just wrap things up there. The quarterly report, the first thing worth noting there from a battery perspective is that all vehicles that are standard range globally will be shifting to LFP batteries. Now, I've already mentioned that earlier in the video. That will free up some nickel-based battery cells that they might be able to use in other places, such as in increasing the Model Y fleet or Powerwalls. The second thing in the quarterly report was that they said that the 4680 in-house cell project continues to progress. We're producing an increasing number of battery packs for testing purposes, and so far the results meet our current expectations. What this is telling me is that cell production doesn't seem to be the bottleneck anymore. In the last quarterly report and in the last earnings call, they brought up issues with the cell production. Now here, it's moved on to the battery pack, which is what I said about 3 months ago. I said my main concern is that the packs will be ready at the same time that the battery cells are, because there's been twice in Tesla's history where battery pack testing or issues with production of the battery pack has held up battery cells going into vehicles. This provides us with a nice segue into the earnings call, so let's get into that. The first question from Say Investors was, when should we expect the first vehicles to be delivered with 4680 cells? Drew responded, early next year. Nice, cut and dry. From a non-cell perspective, structural battery crash, range, and reliability testing are on track to be completed this quarter. Testing to date has gone well. The Fremont manufacturing line is on track to support. In other words, it's what I interpreted out of the quarterly earnings report, which is the battery cells are ready to go. That line is ready to go. It's the battery pack that they need to sort out, so they have something to put those battery cells into. This aligns with all the rumors I've been hearing out of Cato. There's a few other YouTubers that sound like they have connections within the Cato facility, and it sounds like there's separate connections who are all saying the same thing. It looks like everything's green, the yield's good, they're ready to go. There's also some indication in job listings and through informal networks that they're hiring as many battery people as they can now, which is a good sign for the production ramp. Now, there are some different theories as to how Tesla fixed the issue that was brought up in the last quarterly earnings call. And I wouldn't say theories, these are rumors, people who have connections within the Cato facility, but I've heard two different things. I think one is from Galileo Russell, that what they did instead of creating a wider roller is they just used smaller sets of rollers to avoid the dimpling and denting issues with the compression of the cathode material. And the other one I think is from Alex Torville, and he's saying that no, they're going to stick with the big rollers, but what they're going to do is they're going to make that material, for instance, a little bit hotter, a little bit warmer, so it rolls more easily. I think both of those are feasible. I don't particularly care which route they take, so long as they hit the targets that they need to hit. Both of those sound perfectly feasible to me. And it could actually be a combination of the two. So we'll see. We may never know for sure, but what I believe is the case, based on everything I'm hearing, is that they're ready to go, and that's the important thing. Now, Drew goes on to say, this is a new architecture, and unknown unknowns may still exist. Our top priority is ensuring top quality in what we deliver. So he's saying, hey, if we see a green field ahead of us that we can gallop away into, and we can't see anything that's going to hold us back. But As is the case with manufacturing, you almost always run into some sort of issue, but things are looking pretty damn good as far as I can tell. Now, he also says, from a cell perspective, we are comfortable with the design maturity and manufacturing readiness matching the pack timeline I just mentioned. In other words, we're happy with cells, but it's that pack that we're tacking everything to. That finishes things off with the 4680 cell production. It all looks, I can't say anything else there. It looks good to me. Now we just have to wait for that pack and wait for these to start going into vehicles. The next question was, or the next comment was, in response to a question about the $25,000 Tesla. The response was, we don't want to add any new vehicles to our lineup when we're generally in a cell-constrained world. Now, once again, as I said earlier in the video, currently it's chips, but if the chip problem is solved and gradually evolves over the next year, it could turn into a situation where the cells are the bottleneck. But for now, I don't think anybody has a clear view on the way things are going to look for a year from now. But one thing is for sure, you don't want to launch multiple vehicles with multiple supply chain constraints. The next comment comes in response to this comment from an analyst, which is, on LFP packs worldwide, my understanding is that all LFP battery packs currently come from China. Is that the continued go-forward plan, or do you want to develop LFP capabilities in other parts of the world? Great question. The response was, certainly our goal is to localize all key parts of the vehicles on the continent, if not closer to where the vehicles are produced. So this goes back to what I was saying in my LFP patents video, that they really need to localize these LFP battery cells, otherwise they're not going to be getting any cost savings on them. They continued, we're working internally and with other suppliers to accomplish that goal, and not just at the end assembly level, but as far upstream as possible. This is excellent. One of Tesla's critical advantages is their ability to look upstream in the supply chain. And I think there's a lot of battery factories worldwide that are making promises that they probably won't be able to fill because there just won't be the raw materials. It's a game of musical chairs. And Tesla, I think, will have no problem getting a chair. Now, when they say they're working internally with other suppliers to accomplish that goal, I'm curious as to how many LFP suppliers they intend to work with. Because if I was Tesla, I would talk to any company producing LFP batteries that was able to produce a quality LFP battery that they could rely on. And China has a number of companies that should be able to supply to Tesla. So I'm excited there. It would be great if these companies could provide half or more of Tesla's battery cell production. I'm thinking, or I'm hoping that at least CATL, just CATL alone, I'm hoping they'll be able to provide Tesla with about 200 gigawatt hours of LFP battery cells per year by 2025. Now, a lot of people are expecting a lot more than that, but I'm going to be going into that in my next video because CATL is saying 1,200 gigawatt hours of capacity. But once you actually pare that down and convert that capacity to actual produced, and then look at what Tesla's cut of that is, I think it's going to be closer to about 200 gigawatt hours. So let's move on to the next question. Are you seeing costs increase due to increased commodity prices? This is really getting into the core of one of my key interests right now. And the response we got was very comprehensive, so I'm just going to start reading through this. But before we do that, it's probably worth making a note on, there was a lot of people that were disappointed with this conference call, or I wouldn't say disappointed. They found it a little bit more boring than normal because Elon wasn't there. And I missed that as well. Elon has these bright sparks of insight that really, they get your mind going. However, I felt like we got a broader and deeper view in some respects than we normally do. We saw a lot of the people on the conference call talk more than they normally do and give more insight. So from my perspective, it was 6-1, half dozen the other. I'm just as happy with the way that the conference calls are running now. And I think it's critically important that we start understanding these people because these are the people who are going to be taking the reins in the next few years. So if there's this nice transition period, all the better. So let's get into what he said. We have seen an impact. Our primary exposure right now is around nickel and aluminum. Now, the nickel that they're referring to is, of course, in the battery cells, and they plan to solve that by using more iron-based battery cells. aluminum is for the gigacastings. And this is one thing I didn't go into in my gigacasting economics video was I didn't elaborate on what material costs could do to the cost of those gigacastings. I did show that the material cost was a large proportion of the cost of a gigacasting, but I didn't factor in the current aluminum prices. I used average aluminum prices. So right now, it could be very well that because Tesla is using aluminum gigacastings, they might actually be paying more for those gigacastings than they would if they were using steel. However, in the long term, I do see it as a strategic advantage, the gigacasting. But I think it also reinforces what I said in that video, that they may not make the entire body out of aluminum in the future. I think it's going to be a mix of steel and aluminum. Now, I do have thoughts on, there's a rumor that Tesla's going to go for like a 12 or a 13,000 ton gigapress, and I see that as feasible, but I don't think that's going to be the full body casting that people think it is. My guess is what they're going to do is rather than having two separate machines to stamp two separate parts for the same car, what they'll do is they'll take those exact same two castings and just cast all of it in the same machine, which is different from a full body casting or even casting all the body panels. So that we're talking about several different things here that they could do with that 12 to 13,000 ton press. But that's a topic for a separate video, but those are my initial thoughts. Back to the comments. We have a mixture of contracts with various suppliers. Some contracts we contract directly, and we have full exposure to price fluctuations. We do have a number of longer-term commitments, long-term contracts in place. We also have contracts where there's some amount of cost sharing based on movement of indexes. So it sounds like they have a general strategy in place for controlling materials prices, and they're using whatever contract levers they can to get that to balance out well. They go on to say, as these have been moving, some of the costs have been flowing through to us. So it's not a substantial amount of cost, but it's not small. Now that could increase over time as those contracts run out and material prices continue to run up. So yeah, this could become more of a problem over the next year. And as I just said, what they go on to say is, as we look towards next year, I hope it doesn't play out this way, but it's possible we continue to see more headwinds. And to wrap things up, they continued on quite a bit, providing a bit more detail. And if you haven't listened to Earnings Call, I recommend it because there's some good insights there, but I just want to give the highlights here. Zachary Kirkhorn caps it off by saying, what we have to do as a company and what we're intensely focused on is that we need to be continuing to drive down the cost of our products, and we have to overcome cost increases that are outside of our control. We have no choice here but to continue on that path and be even more aggressive in light of the macroeconomics here. And this is, I got excited when he said this because it gives you a sense of the mindset of the company and their ambition and their aggressiveness. I do think they will continue to drive down costs, and I think everybody else thinks that as well. There will be bumps in the road along the way, and I think the upcoming $25,000 Model Q, or whatever you choose to call it, I'm looking forward to seeing that. It's probably going to be, another 2 or 3 years, but I think that's really going to secure Tesla's hold on the market, so long as they execute well on it. It's been amazing to see Tesla execute, make amazing vehicles with each vehicle ramp they've done. There's been no lemons. Every vehicle that they produced has been excellent, which is, I think a lot of people had that concern before the Model 3 came out. And along with every other launch that they've done, people have been concerned. And even especially the Cybertruck, there was a lot of concerns there. But if they just make a smaller version of the Model 3, I think they got it nailed. So we'll see how that goes. We'll keep our eyes peeled. One last note there is some other person chimed in. I didn't know who the voice was, but they also jumped in and said, and diversification. It doesn't need to be nickel or cobalt. There's always some other option. And that's true to a certain extent. And this is why I'm concerned about lithium. We may have sodium ion to fall back on, but it has a long way to go yet. It's going to be probably 4 years before we see that in serious volume if we run into issues with lithium. And finally, after doing recording for about 24 hours now, you can tell I started with the video, it's kind of dark and yellow, and now it's 24 hours later. I'm finishing about the same time. So let's cover off the last question. There was a question asking about strategy for anode materials and the ability to leverage that into a reduction in cathode materials and performance for LFP. So Drew fielded an answer for this question, and there was 3 comments he made. Unlike the commodities discussion we just had, the anode materials are not in the same situation in terms of what their constituents are. They're generally stable commodities. And to a certain extent, that's true. It depends if you're talking about synthetic graphite or natural graphite. Synthetic graphite, that's generally made from fossil fuel products like oil and coal. The graphite that's used for battery cells that's natural is a more specialized product, and you need mining permits, etc. So there can be bottlenecks there. I think most companies would prefer to use more natural graphite because it's cleaner and greener. But if you don't have that, synthetic is always there. And China has just announced, I think, at least 200 gigawatt hours of anode production by 2025. So I think we're good on anode as well. He goes on to say, there isn't exactly tit for tat. Get better anode, use less cathode. There's a fundamental ratio you need to maintain for the cell to function. Now, what he's talking about here is the ratio of energy that each side can store. So if you have the cathode that can store 1, and you say want the anode to store 1, if you increase the energy density of the anode material, that shrinks the anode. But the cathode, if you keep the energy density of that the same, then you use the same amount of cathode. So increase the energy density of the anode, it just shrinks, and the cathode stays the same because they have to have a roughly equal ratio for that to work. The primary focus on the anode side is ensuring we're able to continue to reduce the cost of the anode without impeding on the long-term cyclability of the product. And this is what I've been pounding the table on for at least 6-9 months now about the silicon that Tesla is using in their battery. The longevity of that silicon will determine which products they end up using it in. If it doesn't have really good long-term cyclability, they might not use it in LFP. This will be covered in a future video on Tesla LFP, where I talk about what the implications silicon could have if it has long cycle life on a Tesla battery cell. And even if it doesn't have long cycle life, even if it's decent, what impacts that'll have. And the third thing that Drew said was it can also help with energy density, but the trade space is basically cycling versus 1-day cost. I think that's self-evident. If you put more silicon in a battery, you can lose cycle life, but it reduces the day 1 cost because it increases the energy density and uses a cheaper material. So if you're buying a vehicle, your 1-day cost would be more important to you because you don't need as many cycles out of a vehicle. Whereas if you're going with energy storage, you might hesitate to put silicon in that battery because every cycle matters and makes those commercial energy storage products more viable. I think that's it. Hopefully I've covered off all the questions you had, and hopefully I've added some value to everything that occurred in the month of October. There was a lot there, and I'll do the same next quarter if the same thing happens, which I expect it to. Tesla is a news machine. There's no other company I know of that's just innovating so much that you struggle to keep up with it on a day-to-day basis. So I don't know how Elon does it, or even the rest of the team at Tesla does it on the executive level, because we're only seeing a fraction of what they're doing. They're actually tackling many more problems than we can see. We just see the tip of the iceberg. So they've got some big brains there and a lot of talent. So as always, I wake up every day and I look forward to see what news is there about Tesla. And yeah, I think we're living in a privileged time, and I'm happy to be able to interact and share my thoughts with people about what's going on. And I think I'll leave it at that, and we'll sign off. So hope you're having a good day wherever you are, and I'll catch you in the next video, which will be 2 weeks from now. And I expect it to be on CATL LFP, how much they can supply to Tesla. Have a goodie.